Hello. Hi guys. Firstly, I had already got this entire problem, but then I realized my mic was not working. So let's record it again. Hi guys, good morning. Welcome back to a new video. In this one, problem, maximum points inside the square. Again, we'll see all the approaches. When I mean all, I'll see three. We'll see three approaches. So firstly, the problem is very simple. It simply says that we are given 2D array points and a string s. What they mean? This s gives a tag of that specific point. What I mean? I mean that 2 comma 2, it's the first point. It will be tagged with the a character, first character. Minus 1 comma minus 2, next character b. Minus 4 comma minus 4, d. Then minus 3 comma 1, c. Then minus 3 comma minus 3, a. So this is the tag for every specific coordinate. Okay, now a valid square is a square centered at origin. Okay, this square will be centered at origin and will have the edges parallel to the axis, which means I cannot say a square centered at origin and a square like this. This is not a square for me. For me, a square is centered at origin and the axis should be parallel to the actual axis. Now, and the condition is it should not contain 2 points. What they mean by contain? Do they mean by containing points on the edge? Or do they mean containing points inside also? So they have specifically mentioned for them the point is considered to be inside the square if it lies on the edge or within the square boundary or maybe inside. That what they mean by contain. We have to find the maximum number of points which can be contained in a valid square. So very obvious thing that you have the square, you want the maximum number of points to be lying inside the square. Let's try for all the possibilities. Let's try for the first square. First square will be a distance of 1. Okay, I can see again as I will try for distance of 1, I will have to go and check for all the points. Will they lie inside the square of 1? Again, to check that we will see, but we can visually see it will not lie. Okay, go and try for a next square. Next square is a square having a coordinate of 2, which means a square of 2 comma 2, or I can say 2 cross 2 square. Right, again to represent every square, I know a square will have both the coordinates equal, so I will represent a square by saying max coordinate as 2 because their maximum coordinate is 2. But Aryan, still the question is, okay, you will try for this square and I can easily see that by visualize I can see the character b is here, the character a is here. Okay, and I can see both the characters a and b are different, so 2 as an answer will work. Okay, then you are saying Aryan to try for next square. Okay, I try for next square. Next square, for sure the length of 3 I will try. A 3 cross 3 square I will try. So if I will go and try this 3 cross 3 square, I will have to again go and find all the coordinates inside this. I can easily see one coordinate is c, one coordinate is a, one coordinate is a, one coordinate is c. So c, b, a and a, these are inside my 3 cross 3. I can easily see the characters are repeating and I don't want them to repeat. So for sure, this 3 cross 3 is not the answer. And same way, let's say I go and try for a 4 cross 4. Again, Aryan, 4 cross 4, which means all the things of 3 cross 3 will for sure come in 4 cross 4. So no matter what, any other bigger square will for sure fail. So we realized, firstly, I was going and trying for a 1 cross 1 square, then a 2 cross 2 square, then a 3 cross 3 square, then a 4 cross 4, then 5 cross 5, up till what? I will have to go and try up till a 10⁻9 cross 9 square. And on every trial, as I was trying for this specific square, I will have to go and check for all the points to see that they should lie inside my 3 cross 3 square. That's a task. How I will find that? Again, if I ask you, if I gave you this point 3, I gave you, okay, it's a 3 cross 3 square. Give me all the points inside that 3 cross 3 square. So one very naive way is that I will say, okay, Aryan, I know it's a square. Maximum distance from origin for a square will be its extreme diagonal. So I can easily go and find this distance. This distance will be under root of maximum coordinate, which is in this case 3. So it will be 3 square plus 3 square. So if I consider this square as my current square of a side length 3, so I can just take the like 3 square plus 3 square and take a root, that will be a distance. So any coordinate having a distance less than or equal to this specific distance will be inside my current square of 3 cross 3. So when I have fixed a specific square of length 3 cross 3, then I will have to go and try for all the n coordinates, and out of all the n coordinates I will go and get, okay, for the current coordinate n x comma y, I will get its distance with 0 comma 0, and then this distance, if it is less than my this distance d, which is for the current square, if the current is, let's say current length is 3, so the distance will be L square plus L square. So if this distance between x comma y, again I have to refer all the n coordinates, if this coordinate distance, if this is less than my square distance, let's name it as square distance, then I will say this coordinate will lie inside my square. And after getting all these such characters which are inside my square, let's say, as you remember, I got a b, c and a, I will check any character should not occur twice. If it is occurring, I am screwed up, and I will have to go and try for all of these possible squares. Now the first question is, what is the complexity of this? Currently the complexity is time. Time complexity is you have to go and try for all these possible values, which is, you can see, 1e9, and then for every such length you will have to again go and try for what? You have to again go and try for all the coordinates, n coordinates, and check if they are inside this distance, square distance limit or not. Again O of n time. Usually we have seen when we have this very high number, then again I'll tell you two intuitions. Firstly, we have very high number, then maybe we can either remove it entirely or convert it to a log factor. Okay, log factor, which means maybe we can apply some sorting or maybe binary search. But even if not, the biggest thing is, when I told you, when I was trying for 3 and it violated 3, which means I would not even try for 4 or 5 or 6 and so on and so forth. So that's the biggest hint, that when you were trying, it was okay for a square length of 1, okay for a 2, but violated 3. And no matter what, a square of 4 cross 4 will incorporate a square of 3 cross 3. So it will violate 4 also, 5 also, and so on and so forth up to length 5. What is this pattern called? This pattern is right, wrong. This is a pattern of binary search, which means I can apply binary search on this range. Again, if you don't know binary search, just go on YouTube and write binary search by Aryan Mittal. You will get a binary search playlist. Just watch those videos and you will be good to go. Now we know that we can simply apply binary search on this range of length of squares. So this factor will actually convert to a log factor, and you can simply solve it. Now this is one way you can solve it in n log 1e9 complexity. But you can improvise a little bit by saying that, Aryan, earlier I was going on to all, again I was technically trying for all the squares, which means even if I know that there will be no square at 1 cross 1, still I was trying for that specific square. Okay, great. I will say, bro, again, this will for sure work. This approach will for sure work by the research, but I'm just improvising a little bit. How? I'm just saying, bro, rather than going on and trying for 1 cross 1, again, even if in binary search you try for you will try for 1 cross 1, still I'm saying go and directly go on to, you know that the coordinate b is -1 comma -2. I will get its corresponding square coordinate. It's a square coordinate, which means, what I mean by square coordinate, the square coordinate mean at which square this coordinate will lie. How I can find that? Simply by taking the absolute value of these, which means I'll take absolute of -1 and I'll take absolute of -2 and take the maximum. Maximum is 2. So this will lie on a 2 cross 2 square. Same way I can graph for this 2 comma 2. It will lie on again a 2 cross 2 square. For this point, which is 3 comma 3, it will lie on a 3 cross 3 square. For this point, which is 3 comma 1, it will 3 comma 1, it will lie on a 3 cross 3 square. So I very easily can see they on which square they are lying. Now if I know that on which square they are lying, I can go on from the smallest square to a bigger square, which means I will maintain on a square of 2. I can see I will have a and B. On a square of 3, I can see I will have a C and A. On a square of 4, I can see I will have a D. I will simply go on in the order of these square lengths and I will keep on checking. Okay, the first square I can take this. Next square when I'm about to take, I will check if I've already taken my sum character or not. It can either be in the same row or maybe it can be in the previous row. If I have taken something, I cannot take this and I have to stop here itself. So far whatsoever I have taken, that will be my answer. So with this strategy, what you will do? You will sort these. Again, you have to take a map. You have to take a map which will sort these square values, because I told you, you have to go on in the order of the square lengths. From origin you have to go. So you have to sort the key. That will be useful with the help of a map. And again, I will store only those keys which have a corresponding character associated with them. And at max I have n characters. So at max I can have n keys. And I am sorting n keys. So it will be a O of n log n complexity. So I realized I can improvise this and tell as O of n log n also. But still, we can still improvise it. And my fact, again, that's a bit tricky. It can be asked as a follow-up question. It's a bit tricky that how you can improvise this to a O of n algorithm. Now, for that O of n, you have to make a very big check that this only consists of lowercase English letters, which means that I know this will contain only lowercase English letters. And also I can very easily see that if a character repeats, then it's a violation for me. It's a violation for me. So I know, okay, there's a square, there is this again, rest other strategies, distance, finding square, coordinate, all of them remain same. I have to somehow make sure I use this fact that a coordinate when repeats is a violation. I again have to go in the increasing order of the square lengths. I have to iterate maybe all the characters, and somehow I have to use all the assumptions, all the things which I have seen in the previous approaches and use all of them together with the addition that I will have characters, and that can occur just twice. Use that strategy. How I will use it? Let's see it. So we realized one thing, that at what point violation can come. If I think in respect to all the coordinates, I am telling I will have n such points. Okay, I had a point here D, I had a point C, I had a point A, I had a point B, I had a point A. Same way I can have n such points, and n is very large for me, 1e5. But technically for me I am only concerned of 26 characters, and to be more precise I am concerned of only about 26 into 2 points. But Aryan, why into 2 points? Because for me, as soon as I grab a I am just concerned of when will the next A come. And no matter what, if any other A is coming anyway farther, I am not concerned about it. I am just concerned about if I have already got a, when will the next A come? If I have got a C, when will the next C come? What if the C would have occurred just, let's say, before, at 2 cross 2 square only, then okay, that will be a very danger for me. If I have a D, I'm just concerned when will the next D come. Maybe what if I got a D here and then maybe a D here. So any other D will not matter for me. I'm only concerned about the first 2 Ds. That will be my main bottleneck. But Aryan, what do you mean by first 2 Ds? Will you maintain, okay, nearest 2 Ds or nearest characters? Yeah, technically yes. So what I will do, I will maintain two characters. I will maintain for every character its nearest two squares. So for this A, the first square was at 2, next square was at 3. Okay, I'll maintain this. Same way for C, I'll maintain its first square was at 3, next square was at, let's say, somewhere. Okay, let's say somewhere. C. Same way I'll maintain for B. Okay, the first square at distance 2, next square maybe at some other distance. Same way for D. First square at distance 4, next square maybe at some other distance. Now, my main bottleneck is I can, again, if I go on same way from the square wise, I might end up going on to all these squares. That I don't want. I specifically want that anytime, sorry, let's not erase it. Anytime I will go on to a square, I'll go on to a square. Anytime I will make sure, okay, the first repetition, the minimum threshold or the minimum doubt I have is at a distance of 4. This is the first repetition, or I can say the minimum repetition, which means after at a 4 square, I am bound to repeat. So what I did, technically what I did was I maintained, let's erase this. Now what I did was I maintained for every character what are their smallest two distances from origin. Technically I am maintaining this. Right. Now, to be more precise, I don't need this. I only need the smallest distance. And the next one will make sure that I should never go beyond this. Which means if my next A was coming at a distance of 3, I should make sure whatsoever coordinates or whatsoever distances which I'm taking, I can take only up till my point 3. I cannot go on point 3 or beyond point 3. But how I will achieve this? I will, again, by diagram, let's see it. Let's say that A was at a distance of 2, okay, and let's say a distance of 3, right? Okay. Same way, B was at a distance of 2, and let's say infinity. Other was not even there. C was at a distance of 3, and let's say other was infinity. 4 was at 4, and let's say other was infinity. I'll change this to make sure to actually make you understand. But let's say this is the situation right now. If this is the case, then I will technically go on to all the points. But Aryan, how would, again, you are saying, Aryan, to make this array? Yeah, you can make this also of size 26, and you can take this. Still, even if you go naively, you can still just simply sort this. Again, you can make a vector stating this is the distance, this is a character, this is a distance, this is a character, and you can simply have this and sort this and then simply iterate square wise. You will have this size as 26 into 2. So even if you sort it, still it will be constant, which is log, okay, again, this, if this is 26 into 2, log 26 into 2, which is still much less than what we saw above. But still, do we need to sort it, or we can improve it much further? We can not even need the sorting which we did. Yeah, we can. Make sure we have seen so far 3 improvisations on the same problem. Now we realized that this next occurrence of A is the bottleneck. Technically, it is the bottleneck. So what if this would have been 4, then it would have been very okay for me, because for me then 4 would have been the bottleneck. So again, what if this would have been, this would have been a 3? Yeah, then this 3 is the bottleneck for all the characters. This 3 is the bottleneck. So I will make sure I track this bottleneck. Again, this bottleneck will be the next nearest occurrence than that of the minimum occurrence. Minimum occurrence I have 2. This will be the next occurrence. That will be, again, out of this next occurrence, I will take the minimum of all these next occurrence, and that will be my bottleneck. And what I mean by bottleneck is I will again iterate on these entire whatsoever distance I have, all the distances less than my bottleneck. That will be my answer. So if this bottleneck is 3, I can go on to this 2. I cannot go on to 3. I cannot go on to 4. Anything which is less than my bottleneck, that characters will be my answer. Cool. So I will just maintain this entire stuff. I will maintain the bottleneck for me, and ultimately in the very end I will iterate on all these squares. As you can see, these represent a is at a square 2, a is at a square 4, b is at a square 2, b is at a square 3. That's what it represents. So I will go on to all the squares which are less than my bottleneck, and that's going to be my number of squares. That's going to be my answer. Cool. Let's see the code. It's pretty simple. Firstly, I maintain the corresponding square to every coordinate. So I went on to all the points. I just took the absolute value of the point to get the corresponding maximum coordinate for that specific coordinate which I have, or I can say for that specific point I have. When I have got the maximum coordinate, that will be representing my corresponding square. So this will be a, if let's say if this maximum coordinate is 2, so I can say that this will be 2 cross 2 square. Now you will see that I did not maintain the actual index because I might not need it. I might not need it. But Aryan, why will you not need it? Let's see it. Because I'm maintaining this maximum coordinate, so let's simply go on and try for all the points, all the maximum squares. So as I go on to a specific coordinate, this will say this is a current square. Now at this current square, I will go and check, okay, have I found this square earlier? If not, then simply say for this minimum square, for this specific character, as you can simply see, I went on to all the points and then I got all these coordinates. So these corresponding square is for the specific index itself. No index is altered. So as I go on to the index wise, I am still going on to the points in the order of these points itself. These points are ordered, these corresponding squares are ordered, thus the corresponding string is also ordered. So everything is still intact, ordered. So as I say the specific index I am referring the point of I, which is same way corresponding square of I, which is same way corresponding s of I. Okay, now I have got, okay, for this specific character, taking the reference, let's say I got a. If I'm getting a for the first time, simply again, let's leave this. I'm, let's say, getting a for the first time. Let's say I got a square of 4. Again, this is not ordered, so I can get in any order. Let's say I got a square of 4 for a. Okay, I will, if it's a first time, I will simply update the minimum square as the current square value, which is 4. Again, this is not ordered, so right now the minimum square for a as a character is 4. But let's say next time it goes, next time let's say again character, let's say b comes in, it is, let's say, is saying 3. Okay, I will still update my minimum square of b as 3. Now again, let's say next time my a comes as 2, a is coming as 2. Firstly, I will see, okay, a is already present. If a is already present, then I should, my main task is to make sure I update my minimum square of s of I to my current square value, considering it is less, because it can still happen that I might get a value of 5 also for the a as a current square. For a as a current square, I might get a 5 also. I should not touch this 4 because 4 is already less than 5. Bigger square will not even hamper me. Smaller square, if the square is smaller, in this case the square was a 2. Smaller square can actually replace this because I am only maintaining the smallest square for the character, and this 4, which technically I was removing, this 4 will help me put a boundary, because this 4 will help me say, bro, this 4 was the next occurrence of my same character. So if you will try for anything, make sure you have to skip before 4, right? So I will just make sure that firstly I will check if the current square value, which is in our case, if I'm incoming, if the incoming was a 2, right? If the square value is the current 2, I'm getting a 2 square, a square of size 2 for the correct array, I'm getting that. If this is less, only then you should update your minimum square. So with that current square value. If not, then do nothing. But I'm not saying do nothing. you have to firstly make sure, even if it is less, you got a 2, initially it was a 4, you are replacing a smaller value. Make sure you have to minimize your boundary also, because this is now the second occurrence. If I just show you, this will be 2, this will be 4. This is the second nearest neighbor which you are actually replacing. Again, this was a 4 earlier, you're replacing with a 2. So you are replacing, actually now this 4 becomes the second minimum value. This 4 becomes the second minimum value technically. So make sure to minimize your boundary also. So I will say, okay, ignore bigger. This is the boundary for me. Anything bigger than the boundary or equal to boundary, I will have to ignore. So I'm just minimizing my boundary. I'll say minimizing the boundary, existing value which was a 4. I first minimize my answer boundary. Again, Aryan, why are you minimizing boundary? Because boundary can be for everyone. A has a boundary of 4, right? I'm minimizing boundary of 4. B can have, let's say B also comes in as 2, 3. So this 3 is now the boundary for everyone. So this will be the boundary for everyone. So I will make sure, I will come back and I will minimize that boundary by saying ignore bigger, which means this is the boundary. Minimize this with the current value, which is 4 for us, if you remembered. Now, when this is done, okay, this everything you did when your current square was less than, which means square value initially was a 4, you were getting a 2, and then you did all that stuff. What if you are encountering a 5? Here you did not mention any boundary because the character you are receiving for the first time. You were receiving the character for the first time, so you did not mention any boundary as such. But technically, if the current was a 5, your minimum was a 4, which means you had a 4 earlier, you had a small value itself, you are getting a next value as a 5. So technically this will define boundary now. So that's the reason the current square will be the incoming one which will define my boundary. So even if the current square is bigger, still that can define my minimum boundary. Now, when I have found the actual minimum boundary after trading on all of them, I will simply go on to all my current square lengths. Whatever square lengths are actually less than my boundary. Again, it is less, not less than equal to, because I know equal to will actually decide. I cannot go equal to the boundary also. If it is less than the boundary, I should increase my answer, and that will be the number of characters which I can have. Ultimately, that's the answer. So you see, this will take O of n time to go on to all the points. This will also take O of n time to go into all the points. This will be corresponding square which I have, again corresponding square again at O of n. So this ultimately take O of 3n time. I can say O of n time, and that's my answer. Again, space, technically no space is used other than having a vector of corresponding, that can again take O of n time. So I can just say O of n time for this also, but yeah, that is my time and space. So we saw how we improvised our n log 1 e9 approach to our n log n approach. Then meanwhile we also saw that we can maybe sort it, like maybe we can actually solve it in O of n plus 26 log 26, but that will be bounded by this value, right? But then we realize again, what if n is 5? Then this value will be large, right? That's the reason. So, but then we improvise that to O of n approach, and that is how we saw these 4 approaches in the answer. Now, if you liked it, please smash the like button and please share with your friends so that the channel grows and we get much more motivation to bring these videos. It's very helpful because it takes a lot of time. You see, 29 minutes to just have all the approaches discussed. That's the reason a like and a share will be awesome. If you want to watch most of the videos, then a sub, you can do it. Totally up to you. But yeah, see you. Goodbye. Take care.